while enhancing economic performance. The idea of sustainability goes beyond just the environment, but also the interest of the sustainability of the industry as an industry. The initiative is led by CAST, with me as a chair. It has another 3 core members in addition to CAST, who are all contributing: Ministry of Industry and Mineral Resources, the National Committee of Cement Companies, and the Public Investment Fund, who came on board as well. The initiative is run by a steering committee, which I chair, and has these members, essentially Turki Al-Baktin, who's a deputy minister for mining, Engineer Muslih Al-Imrani, who has been there and helped us establish for quite a year and a half almost. He's General Manager of Non-Metallic. Mr. Shuair Al-Aid is a CEO and board members of Riyadh Cement. Mr. Majid Al-Silan, he's also CEO and board members of City Cement. So the first 2 represent the ministry, the second 2 represent the industry. We have 2 members from PIF, Mr. Robert Hollis and Mr. Abdullah Al-Qahtani, and they from the Investment Strategy Division. And then other members, Kevin Knoll, who is Strategy Business Development CAST, and Ms. Ola Khashoggi, who is a Business Development Specialist here at CAST, who is the secretary in helping us in organizing this event as well. And thank you, Ola. So the focus here is to basically support research, development, and recommendation of effective, agreeable approaches. Is it? Yeah, is it right now? Okay. We'll support research, development, and recommendation of effective, agreeable approaches for future cement manufacturing in KSA. So the scope is basically clinker substitution and emission reduction, energy reduction and lowering carbon intensity, use of alternative fuels and emphasizing circular economy, enhanced carbonation and curing, carbon emission management. And if we're successful, we hope to do pilot demonstrations. We're connecting with international stakeholders, and we want to do educational component and the work on the human capital. So current projects are running. We have projects on looking at clay around the kingdom, assessing it, surveying it, and even calcining it, and making this information available to industry. We want to evaluate carbonation of Saudi cement-based materials. Here we found that the conditions in Saudi Arabia enhances the carbonation potential. That is how much CO2 is absorbed in the concrete over the lifetime of the material. We also want to look at enhancing compressive strengths of concrete by adding functionalized high-performance polyethylene to cement. This is quite groundbreaking research that's happening here at CAST. And also we want to use the high-performance graphene-infused low-carbon engineered cement composites to basically utilize much of the carbon available in the kingdom and put it in cement. For the future, we're thinking about looking into alternative fuels and matching availability and need for cement plants that were not part of the liquid displacement program. We want to look at using magnesium oxides to produce cement, either as a blend or on its own. And we also are going to look at techno-economics of oxy-fuel and methanol production, just as examples of projects that we will be interested in pursuing. We are hosting a national workshop on the 8th and the 9th of December to discuss many of these topics and think strategically about this industry. We're also going to run a free course to industry engineers on the use of RDF in cement kilns run by a specialist from Germany. The last point is to advertise the opening of for a business development manager. If you and others may be interested, we do want to expand what we do, and I'm happy to send the job description. So in general, we need somebody who's familiar with the industry, who understands Saudi Arabia's cement industry, and who is able to work with us to drum up support, preferably somebody with an engineering degree, and or somebody who can also speak Arabic. I'm going to stop sharing in here, and then I'm going to hand over to Dr. Ahmed Ajib Noor, who's the head of sustainability in the Ministry of Industry and Mineral Resources. Dr. Ahmed has a long history of more than 40 years in industry, both in SABIC, in Aquapar, and in Ma'aden before joining the government. Dr. Ahmed, the floor is yours.
Thank you, Dr. Bassam, and assalamu alaikum جميعا ومساء الخير, and good afternoon to everybody who's joining this call. It's a great time to be around, and it's an honor and pleasure to be around. I think the introduction speaks for itself. So we are moving. We want to achieve results, hopefully, and we want to go to actions. We are surrounded today with three great speakers who are really going to give us some insights on what they're doing. We will, of course, highlight their bio shortly. We have Mr. Stephen, Engineer Stephen from NEOM. We have Dr. Ali from University of Dr. Ali from University of King Saud, and we have Engineer Ahmed from SASO. Definitely, we will be going through a very good journey today to talk about the future cement industry, basically. And I know there are many things that you guys know about. I'm not really trying to educate anybody, but trying just to remind ourselves there are challenges in the cement sector. As you all know, it's 8% of the global CO2 emissions is from cement. So we're using, different fuels that is really contribute to a lot of these CO2 emissions. And I think today and in the future, we are going to cover what we're going to do to reduce this, hopefully, and maybe eliminate it. Of course, the other challenge is the demand continue to rise within urbanization, building more building. Traditional processes really rely on heavy fossil fuel and limestone condensation, which is really a challenge. So there may be more challenges, but why now? I think we all know why now. I think we are in urgency with climate action. We want to go to net zero in Saudi Arabia, and many other countries and other private sectors have really announced their really targets to that. The global construction boom, higher demand for sustainable solution, and that's shifting a bit from what we are doing today. So I hope that we will move in the Kingdom of Saudi Arabia to a more sustainable solution. Of course, regulatory and market pressure is a lot higher now for greener materials, and that is known. And we have, for example, NEOM with us today. They would tell us maybe some of their stories about what we're looking for in all new construction material. I think our initiative is a very collaborative platform for innovation. I think the word innovation here speaks for itself. We're going to try to explore lower carbon cement formulations, and as Dr. Bassam mentioned, maybe pilot a carbon capturing in and utilization technology, and hopefully there's already things in the work, and promote circular economy in a way that is really very useful and impactful to the Kingdom of Saudi Arabia and many other countries. Of course, our vision, I hope we have good sustainable cement resilient material. We want to accelerate transition to low carbon and enable greener cities and infrastructure worldwide. I thought just to highlight some of these issues because it's more going into the work, into the action, basically. We want to really join forces across industry, research, and policy, and that's really happening today. We want to drive innovation as much as we can and get to large-scale deployment, hopefully, build the foundation for carbon neutral future, hopefully. So those are, in a nutshell, what we're really envisaging to do, hopefully. And as Dr. Bassam said, this is not the beginning. This is not the end of it. This is just the beginning of the journey. Thank for the Ministry of Industry and Resources. Thanks for the Minister of Mineral, Iman, who's really taking the lead and really sponsoring this. And definitely there is a lot of people around this work. And thanks for the chairman of this team, Dr. Bassam, who would really lead the way. And definitely this will take us through the roadmap and achieve things in a very good way. Of course, there's a lot of examples around us in the world, and we're going to probably hear some of them from you today. I'm very happy to see the cement manufacturer around the table. They are the people who knows how to do it. I think we don't know how to do it, Dr. Bassam, but I think they know how to do it. And I hope whatever we do today, they reflect on them. We're proud of them. They're producing cement so we can live in good houses, we can have good roads, and we can have really civilized life, but we want to make it more greener in the future. And I'm sure they want to do that because it's a really good strategy, and definitely it will bring things up. Income will be better. I think from economical point of view, there are steady research really talks about that. But the pressure is there and the work there. I don't really bog you down with any more of my talk. I think we want to go directly to our agenda, and we will start with our first speaker, hopefully, and just to give him an introduction, quick introduction. Quick introduction to Engineer Steve Khalid, Director of Engineering and Innovation, NEOM. He's the Director of the Engineering Innovation Department. Stephen is responsible for a team of dynamic problem solvers who will really work across key areas to design and construct. This includes key material transformation, design innovation, advanced material, and aligned standard and development. A fellow of Institution of Engineering of Technology, IET. He studied electrical and electronic engineering and hold master in construction engineering from the University of Cambridge. Very high education with a lot of experience, over 30 years of experience in the construction industry. Prior to joining NEOM, he led Curveton Consulting for 20 years, an award-winning firm of consulting and engineering. He founded in 2000. A former board member and treasurer of the Association Consulting and Engineering, ACE. He currently acts as the International Professional Development Advisor for the Institute of Engineering and Technology, advising young professionals throughout their professional registration and journey. I will give the floor to you.
Thank you for the kind introduction. I will share my screen.
Just to give you a head up, Stephen, we're going to have a lot of hard questions for you, so get ready.
Oh dear. I'll share my screen. So if you give me 2 seconds, hopefully that's coming up. Can everyone see that? Yeah. Okay. So I've only got a few slides. I really want to touch on really the sort of performance objectives that we are aiming to achieve here in NEOM and the sustainability objectives. What we have done in developing mixed designs that meet that and the new technologies we've looked at. And then I'd like to just briefly talk about some sort of new materials and things after that. So if I sort of move over to our first slide, forgive me. Concrete sits within the key materials transformation program that we established here in the design and construction sector probably 3.5 years ago, and we started work on concrete as the first piece of work. So whilst we're talking about cement here, our real desire is for high performance concrete that meets our objectives. And we've got really 4 overriding sort of ambitions here. Firstly, for many of our iconic assets, the line, the vault in Trojena, the bow in Trojena, we're looking for extended durability of 120 years plus, which imposes quite significant challenges on us in relation to chloride penetration, particularly given the high chloride content of the ground conditions that we have here on the sea. Also, because we have some large assets, we've got some very deep pores. The raft, for instance, slab for the line is a 7-meter deep raft. So controlling the heat of hydration is managing that heat of hydration is a major challenge for us. I don't know why I've got that twice, forgive me. And then I meant to say in here on this set of slides was the third objective is to reduce CO2 emissions. We have a mandate to reduce our embodied carbon emissions from concrete by 30% from the base economy current emissions. And then overriding all of that is that locally available materials should always be the first choice if they meet the performance objectives. So that's kind of how we've set the piece of work up that we are delivering. And we've looked at three principal areas and have done quite a substantial amount of laboratory and large-scale trials for this to develop a suite of mixed designs that meet those objectives. So the department that I lead is responsible for the technical work as such and developing the template mixes. So what we did was we approached a series of laboratories, both university and private laboratories in Saudi, to develop mixed designs using various supplementary cementitious materials that would meet all of those objectives. And they were, you know, the known technologies of byproducts of other industries such as GGBFS and fly ash. Lot of work with natural pozzolans that are locally available in the kingdom, and silica fume for dense packing and improved durability. With extended chloride penetration tests for each one of those, and predicted service life using software from a Canadian-based firm that would give us this sort of predicted service life from the extended chloride penetration tests that we did. We developed something like 39 different blends of concrete as our templates, and they are presented in a document that we send out to all of our design consultants for use. And then we've scaled those with the cement manufacturers in Kingdom. So we've developed suites of mixed designs from 40 MPa up to, when we get performance driven systems, up to 150 MPa. But our large mixes are in the 40 to 80 MPa range. And we have blends that go from 30% replacement clinker substitution up to 65% clinker substitution with quaternary blends. And we are using those for some of our large foundations at this moment in time. So for the line, for instance, our approved blend is a quaternary blend that uses GGBFS, natural pozzolana, microsilica, and OPC, with a 65% replacement of OPC. So very high substitution rates, and lots of tests for heat management as well. We've done quite a bit of work on clays, LC3, and we have used and calcinated quite large volumes of clays. And what we noticed with the clays was that we had quite a lot of variability across the quarry and low kaolinite content. So we were only able to achieve low strength grades with the material that we had access to. So I'm quite pleased to see that one of the first initiatives that you have is to map out the deposits within the kingdom so that we can understand where the good quality clays are and how that can be used. The other thing that we experienced in developing those mixes was the reaction to the admixtures, particularly the workability was a challenge, and the need to increase the superplasticizers. So we had some challenges for that, but we were able to achieve fairly good quality, but in the low strength grades, 20 to 40 MPa only, and nothing stronger than that. We have done and developed with KFUPM some blends for your ultra high performance concrete, and we're in the process of filing patents for those. Interestingly, for UHPC, we were able to use locally available dune sand without any modification. And that is the technology that we are currently in the process of filing patents for. We call it NEOM UHPC. We had some experience with nanomaterials, so interesting that you've got work and research on graphene. We've used and added graphene. We have experienced some real complications in using it, particularly in developing a homogeneous mix for application. When we were getting good mixing, we were seeing something like an 8% improvement in compressive strength with the applications we were using it for. But we was also seeing where you wasn't getting good mixing, a reduction in compressive strength because of the clumping of the material and the kind of weak spots that you were creating. So potentially higher risk, and we haven't continued to pursue that work. Finally, we have a membership of the Novus Creek Consortium, which is seeking to develop a saltwater concrete, and that is also planning to use modified dune sand rather than other fine sands, so that we can use locally available materials. That's in its early stages, but we're effectively acting as a host for those consortiums so that we can host pilots, etc. So we have the benefit of being able to deploy at scale for known technologies, but also being able to host pilots where new technologies are being brought in. That's pretty much the that we can bring. I just wanted to briefly talk about enabling technologies, because GFRP has been an interesting piece of work, and it leads into my next slides on codes and standards. But GFRP really, as a polymer-based reinforcement, is an enabling technology that's allowed to work in a consortium on developing a saltwater concrete that doesn't use potable water, so that we're benefiting from not using precious resources of fine sands and potable water. We're able to use seawater. We've seen substantial CO2 reductions in the use of the technology, and we are deploying it in a number of our applications. And the numbers that you see here are represented in terms of CO2 abatement are for very, very small substitutions. What was interesting in this was the journey we took in terms of codes and standards, which is one that we would have to, and the Future Cement Initiative, I'm sure, has got in its mind. And with the Saudi Building Code, when Saudi adopted the international code, ACI 440, for GFRP rebar, we identified that there was a problem for us in NEOM because it didn't recognize the use of the material in seismically active regions, which we are. And rather than not use it at all, we entered into dialogue with ACI and with SBC to support the development of appendices to SBC that allowed the use in seismic regions, and that resulted in this code, SBC 311CC, which was launched in February this year, I think it was. And then finally on the left is our employers' requirements. So the document that we produced off the back of all the lab work with the known technologies that we could deploy today now sits in our employers' requirements document. And the way that that works is that you initially have tables that present the various mixes and the durability that can be achieved with those. So if you want a 120-year durability or a 60-year durability, you would look in the table which mix design meets that criteria, and then move on to the constituent components of those mixed designs, such that you picked the one that gave you A, the most optimum available local materials, and B, the most cost advantage. So the ambition here was to develop a large range of options so that the concrete ready-mix players were able to select mixed designs, and our designers were able to select mixed designs that met the performance criteria while simultaneously giving them the advantage of being able to use as much, maximizing the local materials. In terms of the way that concrete production or concrete procurement works here in NEOM, it isn't an area that I'm detailed involved in. I'm more on the technical side, but we have a ready-mix agreement with a number of ready-mix players. They have rates for various concrete strength grades and various performance grades, and rates for each of the constituent parts, such that NEOM, when it buys its concrete, is able to understand the cost build-up for the material that's being poured in the ground, so that if there's a mix that wasn't part of the original pricing, all of the constituent parts were part of that pricing that go into the cost build-up to the supply. I will end there because I could ramble on all day, but hopefully that's a sort of summary of where we are. But having spent 3 years on it, it's probably, I could talk for days on it, but just as a high level summary, that's
thank you, Stephen. I appreciate this presentation and the ambition that you have. And actually, when you presented, you were going from concept to design to piloting to mixing to building, actually, and that's the whole cycle of one. Of course, even before design and concept, you have laid the ground on the ambitious objectives of NEOM and staying green and contribution to reduce the carbon footprint from building material at large, but specifically to cement. I was very glad to really hear about the piloting and many of the work you've been doing. You're a research entity rather than commercial entity, which is you're trying to apply. I think I may just want to touch base on the last part of it, which is the procurement and the building code. I thought the procurement part, as NEOM is set up, is they have I'm sure EPC contractors or some other mode of contractors who would really build your construction. Would that really impact your availability? Because you said it's localized. Are you really procuring internationally, or are you just doing your own production in the mix? And would really the building code actually dictates that type of cement in a way? So just more clarity on really the contractors, who are the suppliers.
So the way the setup operates in terms of procurement here in NEOM is we have contracts that NEOM has in place with 3 ready-mix players. So we actually went out to the market, to the ready-mix players, to enter into contracts where they would establish batching plants, and they would supply the general contractors. Those contracts have rates agreed in them, and they then have worked with us. A really good example is the foundations for the line, for instance. So the foundations for the line, the piles are 2.5 meters diameter and 70 meters deep. So quite a lot of technical challenges with the mix. We picked a mix from the suite of mixes that we developed, and what we found was, to meet all of those objectives, we needed a relatively high percentage of microsilica, 6%, and a reasonably high percentage of GGBFS to control heat, with also a fairly high percentage of OPC, well, high percentage of natural pozzolans, and then the rest made up with OPC. So I think we are 6% microsilica, 30% GGBFS, 35% OPC, and then the rest is natural pozzolan. So locally available materials where possible, pozzolans and cement, and import of GGBFS and microsilica only where they were needed for performance requirements.
Thank you very much for the answers. I think that shed light on what's the possibilities are and what the potentials are and what we can do in the Kingdom of Saudi Arabia. We collaborate, I think, a lot, and I think this platform for the Cement Future initiative is ready to, you know, take a lot of these great experiences and turn them into action. We are having the cement producers here on the call with us, definitely, and they listening to this, and they are analyzing and computing and say how we can give you that material also, because it's going to be the future. I think I don't know, Ala and Dr. Bassam, is it time for asking the participant to raise their hands if they have question for Dr. Stephen?
I think we should leave the discussion to the end. Maybe we go to the next speaker, and then we have.
I appreciate it. Thanks a lot. And we are parking you there, but be ready, Stephen. Okay, there's be a lot of good things.
For the difficult questions.
You made it so exciting and interesting from the beginning. I think everybody is anxious to, you know, hear more from you. I think we're gonna go to our next speaker, hopefully, and it's gonna be soon. We're gonna hear some really amazing things that is going to give us really more light on what we can do with it, especially in academia and linking academia to practicality. You know, Dr. Ali Garni, he's a associate professor, structural engineer, and chairman of the civil engineering department at King Saud University in Riyadh. We are so happy to have him, and it's a big pleasure. I think maybe he can now align and bridge us to what really Stephen just mentioned us. Dr. Ali Garni, he's an associate professor of structural engineering and chairman of the engineering department of King Saud University. He earned his master's degree and PhD in civil engineering. So civil engineering became really the foundational work for our cement work. From University of Texas, Austin. I was there in Austin for some time. Maybe I didn't meet him because I was there before you, Dr. Ali. Respectively, Dr. Garni served as an advisory committee in the Saudi Building Code, and he have a lot of insights. Maybe he can share with us later. And he actively contributed to the development of the national and regional guides and code in buildings and others, including the Saudi Building Code provisions and the HC and bridge the tunnel specifications. A lot of work on that, bridging global practices, and that brings really a lot of benefits and impact to the regional needs. He provides academic leadership in program development, accreditation, and research, aligning departmental initiative with the Saudi Vision 2030. That is really absolutely stunning. His research focuses on behavior of reinforced and pre-stressed concrete, corrosion of enforcement. That's a big area of work, especially corrosion. I know how difficult it is. And recycled aggregates, circular economy part, and innovative materials such as FRB and shape memory alloy that is coming into play with numerous publications in leading international journals. Dr. Garni also leads funded research projects, advanced laboratory capabilities, and foster collaboration with industry and research institute beyond research and teaching. He's very dedicated to academic excellence, quality assurance, and student development at both national and international level. Please welcome Dr. Ali, and now we'll hear from some interesting insights on also the work they've been doing in King Saud University and in the Kingdom and international practices. Please welcome Dr.
Thank you very much, Dr. Ahmed, for the nice introduction. I'll share my slide now. Do you see the slides?
Yes.
Okay. Bismillah ar-Rahman ar-Rahim. Good afternoon. Welcome everybody. Thank you, Dr. Ahmed, also for the nice introduction. I'm very pleased to be a part of this interesting webinar. I will discuss the Saudi Building Code, going over interesting things. The title of my presentation is Implications of Saudi Building Code on Cement Manufacturing. So the presentation is structured into 6 parts. First, I'll introduce the Saudi Building Code mission and vision. I will introduce also the new codes that have been developed over the last few years. Also, I'll talk a little bit about the reference code and benchmarks. Then I'll go into details about the concrete related codes, focusing on design and durability requirements of concrete. This would be a very good segue to low carbon concrete code that was recently published, and then I'll conclude with some conclusion. So the Saudi Building Code defines the minimum requirements for design, construction, materials, and evaluation of building and structure. The aim is to ensure safety, protect health, enhance durability, and promote sustainability in the built environment. Importantly, the SBC is mandatory nationwide, and all design and construction activities must comply with its provisions. So the SBC mission is broad and strategic. It covers preparing regulations, agreements, and checklists, collaborating with different authorities to train and qualify engineers, and developing platforms, manual and handbooks for use by designer and contractors. Another critical mission is representing the kingdom in international forums and ensuring that our code is aligned with global standard while also addressing local needs. So the SBC is built on a foundation of globally recognized code. Among its main references are the International Code Council, ICC. Other references include the American Society for Civil Engineers, ASCE, American Society for Testing and Material, ASTM, and also the American Concrete Institute and other codes. So the development of Saudi Building Code has gone through 3 key milestones. The first edition in 2007, the second edition in 2018, and the most recent 2024 edition. The latest revision was necessary to align with updates in the reference international codes and to ensure full compatibility with the latest version of international recognized code, which our code was built or developed based upon. This continuous updating process ensures that the SBC remain modern, reliable, and competitive. This slide shows the Saudi Building Codes across different disciplines. This is another representation of the code shown according to their cover pages. Approximately, we had about 23 codes in 2018. This slide presents the Saudi Building Codes categorized by technical area, title, designation, reference standard. For example, the General Building Code designated as SBC 201 was developed based on the International Building Code. A similar approach was also followed in the development of the other codes. So we can see from this table the different specialties and disciplines related to the codes, electrical, mechanical, also plumbing, etc. So this slide displays the cover pages of the recently published Saudi Building Codes, which have undergone major updates to reflect changes in the original references. It's important to note that the Saudi Building Code is revised and updated every 5 years. So we started maybe in 2018 with 23, and now we have almost 29 codes. So Stephen mentioned about the Saudi Building Code for GFRP. So that was one of the new code that were developed recently. Now, when it comes to concrete design, SBC 304 is directly aligned with ACI 318. This means that the structural concrete in Saudi Arabia follows the same design principle, strength reduction factor, and detailing requirements. However, certain modifications have been introduced to reflect national condition, such as adjustment to load combination. For gravity load, for example, and concrete material requirements that suits our environment. The 2018 edition of SBC 304 was developed based on ACI 318-14. However, the SBC 304-24 was based on the ACI 318-19, which mean that the ACI is almost, ACI provisions, remain one cycle ahead of Saudi building codes. So the next, Saudi building code after 5 years, it will be SBC, for example, 304-29. It will be based on the ACI 318-25. So that's how the concrete code, is developed and updated. SBC 304, which is the Saudi code for concrete structure, aims to ensure public health and safety by setting minimum requirements for strength, stability, serviceability, durability, and structural integrity of concrete structures. This is a very good, slide where, we can talk about prescriptive versus performance-based specification. Prescriptive specification define exact proportion and methods such as cement content, water cement ratio, and curing practices. They are straightforward and easy to enforce and implement, but can restrict innovation. On the other hand, performance-based specification establish measurable outcomes such as 28 days compressive strength, chloride permeability limits, freeze-thaw resistance. They allow for flexibility and innovation in achieving results, but require proper testing and verification to ensure compliance with the code. I will now discuss the design and durability requirements in detail for concrete as specified in SBC 304. So the value of compressive strength F prime C is defined in accordance with the requirements A through D. So there is limit on F prime C, which is illustrated in table 19.2.1, which we are going to look at it in a second. So we have to maintain and check the compressive strength of concrete by satisfying all these conditions. It has to satisfy the durability requirements, which is in table 19.3.2.1. We are going to be looking at this table in a second. And it has to meet the structural strength requirements. So these are, requirements related to the concrete. And if you happen to be in a seismic region, which is the case in Neom or on the, west coast of Saudi Arabia, then, and you are using lightweight concrete, then there is additional requirements for a lightweight concrete with to ensure that you still have enough ductility and good performance. So with regard to exposure, 4 categories are defined as follow. Exposure category F, which applies to concrete exposed to moisture and cycles of freezing and thawing, with or without the icing chemical. Luckily, this exposure category does not apply in the Kingdom of Saudi Arabia. The second exposure category is exposure category S, applies to concrete in contact with soil or water containing deleterious amount of water-soluble sulfate ions, which is the case for foundation. So you end up having, to meet this requirement and to design your concrete mixes to be able to have sulfate resistance. The third exposure category, W, applies to concrete in contact with water. Finally, or the fourth exposure category C applies to non-pre-stressed and pre-stressed concrete exposed to conditions that require additional protection against corrosion of reinforcement. The severity of the exposure within each category is defined by classes with increasing numerical value representing increasing severe exposure condition. This table presents the exposure category and classes. For example, when constructing foundation, a soil report is required to determine the concentration of dissolved sulfate ions in the soil or groundwater. Based on this information, precautionary measures can be taken and concrete mixes can be designed accordingly. For example, we know that the exposure category is sulfate, but we don't know which classes we are in. So based on the information we have from the soil report, we can identify which region we are in, and then in the next table we'll see what can we do to ensure that we have concrete that is capable to withstand these environmental or harsh environment. Similarly, we can be in any category. So in corrosion, protection of reinforcement, we could be in any one of these. So depending on the situation within this table. So here, this table outlines the requirement for each exposure category. It specifies the minimum compressive strength. Also, as you can see, let's say, these are the exposure classes. We have the maximum water to cementitious material ratio. We have here limitation on minimum compressive strength of concrete, and also we have restriction on cementitious material. So what type of cement we are allowed to use, and if we are going to use supplementary cementitious material, so what other material we are including. There are some restriction when if you are in certain exposure classes with the calcium chloride admixture. So if you happen to use admixture, you have to sometimes watch out for the effect of these admixtures. This is a continuation for the previous table. So this shows if you are in an area that requires the protection of reinforcement from corrosion, so you may be C0. The higher the number, the more severe is the situation. So you can see that there is no requirements on the maximum or water to cement ratio. But if you go to C5, then you are limited to 0.35, and then the minimum compressive strength is 40 MPa. There are other requirements here. For example, you have additional provisions, concrete cover. You have to increase the cover to provide extra, protection for your elements. Recently, ACI, this is a very good segue. Recently, ACI introduced a new code, ACI 323, dealing with low carbon concrete. The purpose is to set a performance criteria, not only for strength and durability, but also for global warming potential, GWP, of concrete mixtures. This marks significant steps forward in linking structural design with sustainability and carbon reduction objectives. So you can see that the whole code, discussion started in April of 2023, and within a year and a half, the code was published. So measurements of greenhouse gases that are released throughout the manufacture, transport, and installation of product or material, which is typically expressed as a kilogram of CO2 equivalent. So the code is organized into 8 chapters and 2 appendices covering general requirements, concrete mixture, GWP, buildings, pavement, bridges, and other structure. It also provides example and documentation to demonstrate the evaluation of carbon budget approach for a certain project. The ACI 323 code is pragmatic. It excludes ultra-high performance concrete and precast concrete, so it's only applicable for concrete with compressive strength between 18 and 55 megapascal. This flexibility ensures that the code can be adopted in different contexts, where environmental exposure and material availability are unique. To enforce these new sustainability requirements, the code emphasizes tools such as environmental product declaration, also life cycle assessment, carbon budget, and benchmark by strength classes. These tools allow designer and regulator to quantify embodied carbon, compare alternatives, and make evidence-based decisions for sustainable projects. To reduce CO2 emissions from cement and concrete, several strategies can be implemented, increasing the use of supplementary cementitious material, SCMs, such as fly ash, slags, and silica fume, calcined clay. Second, optimizing mix design to reduce cement content while maintaining performance. Third, exploring alternative binders such as geopolymer or limestone, calcined clay, cement, different types of cement. And fourth, improving construction practices. This includes the reuse of, or the use of recycled materials, minimizing waste, and enhancing curing efficiency that will ensure that your structure will have longer surface life, and at the same time you are contributing to reducing emissions without compromising performance. Another promising innovation is carbon cured concrete, and this approach capture CO2 is injected during mixing or curing. This permanently sequesters carbon while improving compressive strength. Stronger concrete allows for lower cement content, further reducing the emissions. However, we have some challenges, and these challenges are associated with scaling up production or long-term durability issues, and cost of these technologies. Some of these challenges include carbon pure concrete must meet the mechanical and durability properties requirement of the codes. Performance of carbon pure concrete under severe environmental condition is still unknown, and it requires long-term testing, which in some durability testing will take for about 2 years. Also, it's limited strength. So Stephen talked about, UHPC, high strength concrete. So we have limitation on achieving high strength concrete, and production of carbon pure concrete must be cost effective so that it can be used and be competitive with typical or normal concrete. Also, the lack of long-term durability tests, including ASR, corrosion, and sulfate attack, may limit the use of such technology. So what does all this mean for Saudi cement industry? From a manufacturer's point of view, they will need to invest in carbon reduction technologies, alternative binders, and do some performance verification. For designer, they must integrate environmental criteria such as GWP benchmarks into structural design decisions. And for regulators, they must continue updating the code to strike balance between safety and sustainability. I know that the transition is going to be challenging, but it will open doors for innovation, competitiveness, and alignment with global best practices. And in conclusion, the updated Saudi Building Code align with international standards while addressing, national priorities. It ensures safety and durability, but also promotes sustainability and encourage, carbon reduction. For cement industry, this is both a challenge and opportunity. By embracing performance-based specification, adopting low carbon technology, and aligning with Vision 2030, we can build a safer, more durable, and greener future for Saudi Arabia. With that, I conclude my presentation. Thank you very much.
Dr. Ali, so happy to hear what you just said. I think you took us through a journey that Saudi Arabia is really embarking on, and this journey will contribute definitely to newer material, a lot better resilience. I heard the carbon many times, and I like that very much because I'm more interested also to reduce the footprint of carbon, and as all of us, and definitely Saudi Arabia need to reduce the 280 million tons of carbon. Is it coming from cement manufacturing or is it coming from other sectors? But that's and it was some really good news to my ears, and I think to a lot of people here. Definitely, I think just one quick question on really the comparison. You know, we have Saudi Building Code on construction, as you rightly said, and it took a lot of stages and steps to correct that, measuring the international codes and trying to compare ourselves. Are we in a way comparable to others when we talk about the Saudi building codes and other countries? I understand it is really coming from other different international standards, but we have developed our own, let's say, localized requirement. So when we do benchmark in a way, that's the first question. Are we there? You know, are really better? Are we tougher? Are we really more resilient in our code? The second one, are we really measuring the building codes, especially on the cement part of it, and on the ground? Do we really have, you know, performance numbers? I maybe hit you cold, but whatever answer you have, you can share with us on the benchmark, on the codes, as well as really numbers on what really happening on the performance itself when we are really putting this new material in the buildings and the roads and so forth. Thank you, Dr.
Thank you very much, Dr. Ahmed, for your question. With respect to the first question regarding the comparison with international codes, for example, Saudi Building Code, SBC 304, Saudi Building Code for concrete structures, which is the equivalent of ACI 318, in terms of, you know, material requirements and concrete requirements for strength and durability, we are more conservative than the ACI. So we are on the conservative side, even, you know, in some design, you know, requirements. So we still have the 40%, you know, factor of safety dead load and 70%, you know, factor of safety for life load. Whereas the ACIs, you know, we're able to reduce it to 20 and 60, you know, so we are a bit on that. But from a material point of view, if you compare, you know, the same table for Saudi Building Code with the ACI 318, the ACI can go to a lower compressive strength, while Saudi Building Code maintain, you know, threshold of 20 MPa as minimum, you know, compressive strength. Similarly with other things, you know, so that with respect to the first question. And for the second question, you know, as structural engineers, we do not go into much details with the, you know, okay, of course, cement is an integral part of concrete. So, but at the end of the day, if you ask any structural engineers, he would say, okay, I want my concrete to satisfy or meet the strength requirements because this is what, you know, I'm responsible for design. Durability is a long-term, you know, test, you know, and it requires, you know, doing, you know, some tests will take for durability, especially for ASR, will take about 2 years to get a result. And this, you know, goes back to the code itself. It's prescriptive based specification. So it tells you if you happen to be in that category, this is a minimum requirement. At the end of the day, and we talk about, you know, the code provide minimum requirements. We can go beyond that, but it will increase the cost on, you know, the projects, and that might, you know, hinder, you know, innovation and technology and implementation. Whereas performance-based, which is, is not up to this point being utilized, globally, for building, maybe certain codes, have adopted this approach where you do performance-based, and at the end you verify whether or not you have satisfied these requirements through testing and validation. So this is, I hope that I have, answered your question, Dr. Ahmed.
Probably there will be more follow-up questions later on, but I really thank you for your generosity of sharing your knowledge and your science with everybody. Plus, I think the future is shaping now, I think, on the future of cement. I guess that will take us through the third speaker, who will really give us more insights on how we really turn this work. I mean, on the building code, we have a code, but I think SASO is more interested into looking at the final consumer, and I hope that we will see the roadmap also on how standards are really developed in the Kingdom of Saudi Arabia from SASO perspective, and specifically the cement. I think you already see the presentations coming up, but thanks for our previous speakers. But now we're going to go to Engineer Ahmed Al-Khatlan. Ahmed Al-Khatlan is a director of construction on building standards. So we are going back to construction. I think the future looks so bright on that. From SASO, he holds master's degree in sustainable engineering from University of Stuyvesant. I hope I said the name correct, where he graduated with honors. Mabruk for all of us. He has extensive experience in developing and managing and implementing standards. Great. In construction sector, focusing on safety again and sustainability and alignment with international best practices. Engineer Ahmed also previously managed the quality mark department in SASO, supporting and protect products certification and compliance. Of course, in Saudi Arabia, we fully relies on SASO as a final consumer. When I see a product that has a SASO stamp on it, I believe that product is going to serve me well. It is safe for me, for my house, for my children, for our future. And I hope the future generation definitely will see that impact from what we're really doing in the Kingdom of Saudi Arabia. Please welcome with me Engineer Ahmed Al-Khatlan to take us through the journey on the specifications and also the standards and how they are developed in Saudi Arabia. And then we'll maybe ask a few questions. And at the end of the session, we'll give the room and space for participants to ask questions on the subject. Tfadal, Mr. Ahmed, Engineer Ahmed, the floor.
Thank you, Dr. Ahmed, for your kind introduction. First of all, I would like to thank King Abdullah University and Professor Bassam for inviting us to participate in this webinar. Today in this webinar, I am going to talk about cement standard and the mechanism of introducing a new product. So I will start. This is the content. I will start with the Saudi standard definition and the importance of the standard. And after that, I am going to talk about the National Technical Committee. And next, I will talk about the participation in regional and international technical committee. And after that, I'm going to talk about technical committee for concrete and cement product. Finally, I will present the approved standard that already approved by SASO. So let's start with the definition. The definition of standard according to SASO point of view is a document prepared and approved by a recognized body for general and frequent use. A standard set requirement or guidelines related to activities or their result for organization and manufacturers to follow. The standards are important for manufacturers and laboratories and engineers and consumer and government sector like Saudi Building Code and Road General Code. The standards are also important for importers and exporters and also important for certification body. So this slide presents the importance of the standards, which are reducing cost and increasing productivity.
Engineer Ali, the slides are not moving. Is it my computer or there's something wrong? Because nothing is moving. Just
So do you think I should stop and share
no,
it
no.
again?
It just I don't know what's because we only see the first slide, which is the introduction to new products. Other slides are on the side, but they're not really moving unless. So maybe you can put this on PowerShow. Yeah, we can see you very clearly, but we'll see. Maybe you can continue talking. تفضل يا Ola. There's anything we can help Engineer Ali with?
Yeah, he can just stop sharing and do it again.
So now, do you see it?
Yeah, we see the first page only, and the other page is on the side, but we don't see movement.
So let's move like this.
On
I
a full
think,
screen. Yeah. Now, yes. Now we see the content. Yeah, now
Okay.
introduction to Saudi Arabia standard. Now it's moving, engineering.
okay,
Is
so
it
this
possible you
slide
can put it on a? Is it possible you can put it on a full PowerShow? The
I
full
think
screen
it's,
from the left side of yes, appreciate.
I have tried that, but it doesn't work. I don't know why.
Maybe because you did not pay your internet bill, maybe.
No,
Or Chaos is blocking us or something. I don't know. Now you can go ahead and move it manually, please. I don't want to waste more time.
okay.
تفضل.
So this slide presents the importance of using a standard, reducing cost and increasing productivity, facilitating trade and strengthening visitor confidence, enhancing sustainable practices and protecting natural resource, enhancing quality, safety, and consumer protection. This slide presents the technical department that we have at standard department. We have 7 technical departments. There are technical teams under each department. So today we are talking about cement. So cement is under the construction and building materials department. We have here 6 technical committees: sanitary wares, steel products, green building and sustainability technical committee, concrete and cement products technical committee, fire safety, finishing materials. The total of the technical committees that we have are around 52. This slide presents the aim and the importance of having a technical committee. Through the application of technical committee system, SASU aims to develop the process of preparing standard by providing equal opportunity for governmental research and the private sector to participate in the work of technical committees that prepare a standard for a specific subject. The technical committee's objectives are promote the participation of relevant body, follow up draft standard prepared by international organization, achieve economic, environmental, and social benefit, support national industry and enhance competitiveness, raise professionalism in developing Saudi standard, review standard regularly. This slide presents the structure of General Department of Standard. We have technical departments as I explained in the previous slide. We have technical committee. The technical committees consist of a chairman and members from public, private sector, academic, non-profit. Also consists of secretary. Secretary always belong to SASU. According to the technical committee's decision, SASU can establish a working group, WG, to working on a specific topic to prepare a standard or modify a standard. Also, according to the decision of the technical committee, SASU can create a TG, technical group. The aim of this technical group to study the international standard This is when we participate in ASTM or ISO or AN. This slide presents the stages that we have for preparing the standard. So as you can see, there are 6 stages. The stage number 1, new proposal. So the proposer will fill out the form STDP 52, and SASU can help with that also. And after that, studying the proposal by the technical committee. And after that, maybe the technical committee will ask for looking for more additional references. And after that, approve the proposal or request additional information. And the final step in this stage, establishing a working group of experts and stakeholders. The stage number 2, working draft, WD. In this draft, in this stage, the working group should prepare a draft, standard draft, which include scope, references, requirement, sampling, test method, markings. If the proposal is to adopt a standard, this step is not required. If the proposal is to adopt a standard with national amendments, an annex containing these amendments must be prepared. The stage number 3, CD, stage committee draft. What happened in this stage, the committee will study the draft, and if the draft shall be approved by consensus, and if that is not possible, the voting mechanism shall be applied. And after that, the stage number 4, the draft standard stage. We are doing in this stage distributing the draft for public comments for 2 months on SASU website and to relevant stakeholders. And the stage number 5, final draft standard. If no comments are received, the standard shall be prepared in its final form and submitted to the technical department. If comments are received, they shall be discussed with the technical team and the working group to make a decision regarding them. And the final stage is the standard stage, approval of the standard by the steering committee, approval of the standard by the SASU board, and the final step is the publication of the standard. This slide show the organization, the international organization that SASU participate with. We participate with ISO, we participate with the ASTM, we participate with Arab Industrial Development and Mining Organization. We participate with GSO, Gulf Standard Organization. For EN, we have agreement that allow us to adopt any standard that is useful for our markets. This slide show you the ASTM International Committee, which I think is the most important technical committee for us because we are talking about cement. And the ASTM standards are a reference standard in the Saudi Building Code. So this is the most important one for us for participating internationally. This committee was formed in 1902, meets twice each year in June and December, about 100 members attending over 3-day session. CO1 has 19 technical subcommittees. This slide shows you the key points of the importance of participation in regional and international standard committees. The first one, influence the rules. Participation allows us to directly influence the creation of new standard or the revision of the existing ones. This ensures they align with our national interest and local technology, preventing standards that might create trade barriers. The object number 2, gain expertise with and knowledge. These committees are a platform to exchange knowledge with the global experts. We can stay updated on the best practices, which helps improve local skills. Object number 3, enhance global trade. Unified standards make it easier to trade internationally. This makes local products more competitive in the global market because they are proven to meet accepted international criteria. And after that, the object number 4, protect the local market and consumer. Active participation helps in creating national standards that protect consumer from non-compliant product and improve the overall quality of goods in the local market. And the final object, avoid wasted effort by coordinating with international committees, countries and companies can avoid spending time and resource preparing a standard that already exists internationally. This slide shows you the National Technical Committee for Concrete and Cement Product. The scope of the Technical Committee is preparing and adopting standard for concrete and cement product and their method of test. The members are King Faisal University, and the chairman is Dr. Abdurrahman Al-Fahid. He's the chairman of this technical committee. And member number 2, Yamama Cement Committee, and Savitu, and Suruh Al-Mashari' Ready Mix, Ministry of Municipalities and Housing, Saudi Building Code, National Industry Development Center, Tafsir Company, Dow Company, Ministry of Industry and Mineral Resource, and SASU. The International Technical Committee that related with this technical team are ISO TC 71, concrete, reinforced concrete and pre-stressed concrete, STM CO1 cement, ISO TC 74, cement and lime. And it's important to know that this technical committee is a standby from a long time. ISO TC 77, products in fiber reinforced cement, and also this technical committee is a standby. This slide shows you the standard that already approved by the technical committee and SASU. As you can see here, we have around 15 standard for cement. The first one, standard specification for Portland cement. This is the famous cement that used in the market. We have expensive hydraulic cement. We have hydraulic cement. We have plastic stucco cement. We have rapid hardening hydraulic cement. We have standard specification for blended hydraulic cement. And if you are interested in green buildings and green practices, this is what you're looking for. This is the most important standard for you. Check this standard. You will find there are 4 different types of the blended cement. There are Portland cement mixed with slag. There are Portland cement mixed with limestone. There are Portland cement mixed with pozzolana. And the good news for this standard, SASU already certified many products, and they are available in the market. If you can go to SASU application, there is application prepared by SASU. It's called Ta'akkad. Write the pozzolana cement and you will find the manufacturer that gets certification from SASU. We have also cement, masonry cement. We have standard specification for mineral fiber hydraulic setting thermal insulating. This is cement for thermal insulating and finishing. We have also slag cement. This is for using concrete and mortars. Let's move to the next page. We have also his more standard that approved. We have here packaged dry rapid hardening cementitious materials for concrete repairs. We have mineral fiber thermal insulating cement. We have silica foam used in cementitious mixture. We have also cement, natural cement, and we also approved the EN standard because it's widely used, and it's already approved also by GSO, Gulf Standard Organization. And if you are interested in the green practices, you will find in this standard many type of cement that has less negative impact on the environment comparing with other type of cement. If you are interested in any standard, please visit SASO website and write down here the number of the standard and you can get it. And thank you for your attention.
Engineer Ali, thank you very much. Also, we have been blessed to hear a lot of the great achievements and work that SASO is doing, and all those 15 standards, which is at the end, I think that means a lot in connectivity to the work that has been done with the Saudi building codes and the actual work that is being done on the ground by NEOM. I think there's a lot of linkage between theory, standards, documentation, compliance, and the actual work that is being done. I just have a quick question. I heard the word green from you several times and probably heard the word green from the other speakers. I'm not really sure as we are linking to ASTM or other international standard, are we looking at the green building codes, the US Green Building Code, the LEED? Is LEED is anyway part of our focus here, Engineer Ali, and maybe the other speakers may jump in because I haven't really seen that coming up. Thank you. Is it clear? We can hear me?
دكتور علي ولا أحمد؟ أنا
أحمد آسف المعذرة منك مهندس أحمد.
دكتور
أحمد
فرق
مش مشكلة.
كلنا واحد.
I'm talking to you. I'm addressing to you on the green building codes, the LEED. Is the LEED is any part of this work?
Dr. Ahmed, I will talk about the standards. SASO, when we say green, this is name used in the market. I think it's not right. There is nothing called green cement. It's Portland cement mixed with different materials like slag, limestone, and pozzolana. This is blended cement. The right name is blended cement or Portland cement mixed with these materials. There is nothing called green cement. For the green code, I think Dr. Ali Al-Garni, maybe he can answer this question.
Yeah. I thought maybe that's why maybe my mind went both ways to Ahmed and Ali, but maybe Ali can give us, because he emphasized a lot on the building codes, and I understand that the US Green Building Code is also a player in all of this. So maybe quickly, because we are, I'm sorry, we have passed over time or close to our time, and participants may be interested, and I think the topic becoming more interested and dynamic, so we want to hear more, but we not really take a lot long time. Dr. Ali, please.
Okay.
Thank you. Thank you.
Thank you, Dr. Ahmed. Thank you, Engineer Ahmed, for the explanation. With respect to the Saudi Building Code, the LEED is not considered because LEED is giving credit for materials, for ventilation, for lighting, and etc. So the Green Building Code in Saudi Building Code addresses the material aspect of the code, while LEEDs and other green building initiatives and other international initiatives that promote sustainability is not being considered currently in the Saudi Building Code. These are still being in process for Saudi Building Code, and they are guides for certain materials and specifications. As for green, I would say anytime you use recycled material, you use binder to minimize carbon emissions, to reduce the the cement content in your concrete, then you have green concrete. So green is associated with environmental impacts, and I think the confusion between designers and people when mentioning green, they associate green cement while it's green concrete, because at the end of the day, instead of starting your mix design with, let's say, 250 or 350 kilogram per cubic meter, by including these supplementary cementitious material, combining it with recycled aggregate, that of course will reduce the carbon emissions from early on stages of material transportations and other things. So you are contributing to reducing carbon emissions. So I would say there is green concrete, and we are pushing towards using green concrete, provided that mechanical and durability properties are not compromised. So sometimes you get a reduction in compressive strength and sometimes in workability on the site itself, but you want to make a balance between these two elements.
Agree with you. Thank you, Ali. I think Dr. Ali, Mr. Ahmed, and Stephen have done a great job today to really enlighten us. And we are in action mode. We're not really no more in theory or building concepts. We are really in action mode in Saudi Arabia. Ms. Ula, Dr. Bassam, do we have time to have the participant to ask questions in the chat, or what do you guys think?
Of course, anyone can. Of course, anyone can just start. Just raise their hands. Already there is engineer Ammar. Ammar, I already unmuted you. If you just want to start a question.
Okay, Engineer Ammar, don't ask me, ask them, okay?
Thank you very much, Ola. Thank you very much. I would like to thank everybody for this gathering. It's really useful to have such conference with the high-end educated people to work or to do the business of the CO2 emission control. I would like to. I have two questions, but very small comment before raise the question. I would like to bring to your attention that we, Rashid Cement Company, we are the first manufacturer commercially producing the GGBFS. One of the main products has been come in the introduction or in the presentation of Dr. Ali here, and even it has been mentioned by Professor Bassam earlier. So recently we got the EPD certificate that reduced the CO2 emission between the cement 850 kg per ton up to 153 kg per ton. Of course, it will go with the percentage side. I am announcing here to all this, to the gentlemen with us, that myself as a CEO, as well as our lab on Riyadh plant and our technical team will be under the service all of the gentlemen. If they have any issue related to this subject, we are ready to contribute in this matter. We already trying to make an education for the new generation of the engineers. We educate them, we give training for them about the SCM material, what is the impact of that, how to go to that, as Dr. Ahmed mentioned, the green concrete. It's not a concrete green, but as a part of the contribution of the SCM. The two questions what I have it to the gentlemen with us. First question to Dr. Ahmed, to Dr. Ali, sorry, to Dr. Ali, Dr. Ali Al-Qahtani, that he already mentioned in the SCM, already specified that there are cementitious material that it has to be used, especially with the critical areas where the concrete has to be used, especially when in the foundation. But my question, how to make sure that whatever has been specified in the on the Saudi code, that it is really implemented at the site, at the work? Who will guarantee that this specification is really follow up? I have, and I can declare from my side what we are facing at the site as we supply this material to most of the ready-mix concrete companies across all the kingdom, from the north to the south and from the east to the south. There's some ways with other countries that we could bring it attention later on, not in this presentation, how to make sure it's implemented. But my question now, is there is any way that whatever comes in the Saudi code building material that really applied on the ground? This is the first question to Dr. Ali. I will ask the second question, then I will leave the speak to the gentleman in order to answer. The second question to Dr. Stephen on Yom, that is there, since there are manufacturing of the locally the GGBFS as well as the Buzalan, which is both are manufactured from local companies like Rashid, that we are producing both these products as well as we supply the other SCM material, the silica foam, as well as the fly ash. Is there any priority to use the local material manufactured or give them opportunity to be rather than to import the material? Because in your presentation, you said that the GGBFS has been imported while we are local manufacturer here in Saudi Arabia, and we are producing the material as a first manufacturer in the KSA. Thank you very much, and sorry if I took longer than needed. I don't want to take more. Thank you, Jitu.
Thank you very much for your questions, and that's a very excellent question. So I know that's okay. What we have specified in terms of maximum water cement ratios and also minimum compressive strength and the type of cement to be used plus additional requirement. Ideally you would like to have these implemented on the ground. But from a code point of view, the code, is like, a legislative, authority. So it's not the responsibility of the code to go out and do the inspection. It's the responsibility of other governmental, entities that are supposed to take part of this and, start monitoring, the concrete plants and also the construction. I think inspection is done for residential buildings, for example, at different stages. There is, you are required to have, engineering office, to do checks. But these checks are mainly on, reinforcement layout, cross sections and, detailing. So it doesn't go to the depth or, to the level where it can, measure the microstructure or identify the microstructure of concrete. All they do, they maybe cast concrete cylinder and then they test it after 28 days to check that whatever they have specified is, is achieved. It's a serious issue. I agree with you regarding this, but on the long run, it will affect durability if, these, guidelines and requirements are not implemented. It will have negative consequences on the structure. So I think insurance might, and other municipalities are supposed to have some strict, regulations regarding, inspections and checklist on these, either, contractors and, cement or concrete plants to ensure that they are, in full compliance with certain types. What's happening now is once you order, you call the, I have, I want to order, concrete for foundation. They will, they do have their own template, concrete mix design, and they will implement it. But sometimes you may have, severe exposure category that requires more than what they are, providing, So that's, I agree with you. It requires, some sort of, integration between different entities to ensure that we have, meet the requirement of the Saudi Building Code with respect to these, material, mechanical and durability requirements.
If I take the question that was addressed to me and related to the imports, I may have misled you slightly in the way that I expressed it earlier. So, as you know, there is no production of blast furnace slag in the kingdom. So the granulated blast furnace slag has to come from overseas, unless you have another source that's in the kingdom that we're not aware of. But there are no blast furnaces that produce granulated blast furnace slag in the kingdom. So the granulated blast furnace slag has to be imported, and presumably you're importing that yourself. But the process for us, the processing of the ground granulated, so the GG, is produced in kingdom. So we are having that locally produced. It's not imported.
Thank you.
Hopefully that's clear.
Okay, so we have two people. They're raising their hands. Your mic is open. Please, you can just start, put your question, or you just go ahead.
Okay, maybe I go to for the first question. And can you hear me?
Yeah, we can hear you. Go ahead, you.
Okay.
Go ahead.
Hello, everyone. I'm Kongqi, the new assistant professor in KAUST, and Professor Hussein Houtet is our chairman. And very happy before joining the KAUST. I also come from the UT Austin, so always very happy you mentioned some story about the UT Austin there. About the topic on the concrete, to be honest, I'm also very familiar because my wife and her topic is on the concrete. And also her topic is on the how to add some CO2 into the concrete. And she also working at the UT Austin, and then she continued and postdoc at the Hong Kong Poly University, and now she bring his knowledge about the concrete to the KAUST. And I think in the near future, she will also find a job on the concrete. Well, however, my background is on the numerical simulation. And I know most of the story about the concrete from my wife, and most on the experiment work. So I do have the one question, just like do your expert in the concrete, do you need some of the simulation work, or how our simulation can help you to, to further explore some of the research on the concrete? Yeah.
Good question. I think maybe this is Dr. Ali, or maybe even Dr. Bassam can answer. I don't know. Thank you for the question. Great question.
Thank you.
I mean, there is opportunities to do, of course, computational research. Most of the time, it is mostly experimental, and because that's what the standard says. It can be used for planning, of course. There's codes for carbonation, which I know, I'm aware of, and of course, we could delve deeper into the microstructures and how different polymers and additives can impact on this. It's more on the low TRL, and much of the work we're doing here is a little bit more sort of on the applied side of things. So there's opportunities. I think perhaps we should talk about where you could contribute in the future. But for this audience, I guess from the industry, it's a little bit too scientific for what they need now, where the standard says, can you blend something that I can use and it fits the standard? But let's talk, and I think we could sort it out.
I think this is a great intervention from Kanju, and I think him and his wife, the work they're doing probably can really help also this, and it's scientifically definitely is going to add value to us. And I'm happy that we have other members are joining us from KAUST, and this is really great. I hope you get the answer, and I hope you will do a lot of work for us, my friend. I'm sure.
Thank you. Thank you.
Okay, Ola, anybody else?
Yes, we have a Zoom user.
Yeah, I think Ola, that's me. الله يعطيكم العافية. شكرا جزيلا. أخوكم ماجد العسيلان.
أهلا حياك الله. Now it is becoming very impactful. حياك الله.
الله يطول لي بعمرك وشاكر صراحة. My great pleasures to the wonderful speakers. It's very informative. Thank you, Dr. Bassam and FCI, for all of the great job that we're seeing. I mean, just a quick, it's not a question, could be a clarification to Dr. Ali which صراحة he showed a very intensive and strong presentation, and I think we feel so proud in the cement industry having such codification or such clarity and trajectory and pathway. So this is excellent. Just I don't know, kind of a clarification. You're absolutely right. There is a green concrete, but following the same concept and philosophy that less CO2 or less carbon in your final product that can drive to a green product. So we can see on the other side, cement can be green as well by lowering the carbon footprint. And I think everybody knows exactly the scope 1 and scope 2 and scope 3. In scope 1, you can look at your CO2 comes from two. It emits from two resources, if you wish. The chemical reaction of the raw material and the fuel that you are using in order to generate the heat. So the lower CO2 in the heat in the fuel or fuel type that you're using, that will lower indeed the carbon or the CO2, and that will make you legit for lowering your carbon and claiming that it's green cement. The issue here, there is no standard, there's no definition. How would you decide how greener it is? It doesn't make sense to call it a green cement, but again, following the same concept, that can be happened. I think today, seeing at some companies issuing their own EPDs, which at least a very excellent model to show exactly what's the carbon footprint in your product or your cement, that will help a lot and will give a better option to the downstream, which is the concrete producer. So this is just a clarification. We don't want to be labeled as as a cement manufacturers that we are not able to produce green cement. No, we are following the same concept and philosophy that Dr. Ali used. On the other hand, I think GGBS and other supplementary cementitious materials, SCMs, imported. I think, yes, there is scarcity here in the kingdom or rarely to be found. Although we have to look strategically, the sources of GGBS, this technology of steel, and we're shifting from electrical furnace arc and not using, coal or burning coal internationally or globally for a lot of restrictions that will lower down the quantities produced of fly ash or GGBS. And it should start looking at the local potential material. I know that there is some initiatives of producing a calcined clay in the country, looking into either to be used in the downstream or even a potential LC3 down the road. And I think there is a plenty of very excellent deposits of clay being tested internationally. So I think there is a very great bright future for the minerals here in the kingdom, and this will definitely improve big time the carbon footprint. It will improve economically or the GDP and etc. So I think everybody is doing a great job. Ammar with his company, they're doing a wonderful job applying, addressing the market, but there is a great potential. And I think only having such, webinars and gathering, bringing the whole stakeholders together and to understand what's going on, that's what will make, this is the right and real enabler to decarbonize, this industry. And thank you, gentlemen. Thank you, Dr. Ahmed. Thank you for the opportunity. Thank you, Ella. Thank you, Dr. Bassam, and the rest of the attendees.
Thank you, Majid, for being with us. I think, I don't know, Ali, this is the last...
No, still the people from ACC.
Assalamu alaikum. This is Walid Abedat from Arabian Cement. I want to thank you for this valuable information from our from a professional expert. It is sure it's very nice and very valuable information. Thank you first. Second, I want to highlight one issue. We are talking about SCM, supplementary cementitious material, and most of the people in the world, they are concentrating for LC3, slag, other like fume, like which all of this material are bypass or byproduct from other industry who are producing or emitting CO2. Where in Kingdom here, we have pozzolana, which is from nature, found by nature without which volcanoes which happened before already happened, and it is now available in the kingdom. And I believe the kingdom is one of the highest reserve of pozzolana in the world, where the other material is imported from outside. And it is, for example, for slag, byproduct, where they are using slag or coal to produce this steel or steel industry, where pozzolana, it is from nature. Come on. This is one issue. We have to concentrate. I agreed with Mr. Ahmed Al-Katlan and Dr. Ali. Dr. Ali escaped from the answer about the green cement. Yes, there is no green cement. As we are producing or using 10% or 20% and or using or firing material to produce clinker, it is ungreen. The green houses or green cement, it is old mud houses for 50 years and before. This is the greenhouses. Now there is no green. It is a blended cement. My request to Dr. Ali and Sasso and the committee that to concentrate for pozzolana. Pozzolana in warm weather countries like the Gulf area and Africa, the growth of strength continue for about 100 days, not 28 days. It continue about 100 days. This should be considered. Second, we can, if we want to reach the highest strength, we can reach, for example, minimum 30% pozzolana, plus 5% gypsum, which means we are using 65 clinker. This is in the range of green cement as they mentioned. And we can reach by strength enhancement material, the required or the required strength. So no need to use slag or sand clay and or other or to fire a clay to produce. Again, I am firing or burning a clay, calcining a clay, to use it again as additive to produce LC3. And other impact for this clay is desert crawl, which is affecting agriculture or agriculture land. This is the issue. I want from code, Saudi code, I think it is a professional association, and they did great efforts. Now need to concentrate for pozzolana, using pozzolana cement PVC in different grades to compensate all other SCM. Thank you very much and appreciate your efforts and your valuable information. Thank you.
Thank you very much for this.
Dr. Ali?
Thank you very much for the questions. I think such webinar will help, fill in the gap between, industry and academia and regulators. So, these are really important issues. And of course, coming up with, feedback, comments, suggestion will be considered at the Saudi Building Code, and it will be looked at carefully to investigate whether or not modification should be implemented in the code. But again, the code is associated with references international code. So any modification to the code has to be, achieved through, process, and that process include, technical committees, etc. So that's one thing. And the other thing is, I want you to remember that, the code provides the minimum requirements for, for design and, whether for materials and etc. So you can go beyond, if you want to design your structure to be, beyond these minimum requirements, you are allowed to do so. But in order to, approve this, technology, it has to be validated with some testing, to ensure that not only on the short term, performance, but also the long term, durability are satisfied. And I welcome everybody to, provide any suggestion and comment to SBC and SASU. I'm really sure that it will be looked at, very carefully. And
thank you, Dr. Ali. So we have a question from Mr. Mu'tasim to SASU people, to Engineer Ahmed. SASU C595 is for blended cement, only finishing, not for concrete and infrastructure foundation. Please confirm, and what is the alternative in this case to fulfill less carbon emission in the cement?
This question
to Engineer Ahmed.
Engineer Ahmed from SASU.
The standard doesn't specify exact applications. It's only defined the requirement for blended hydraulic cement, which are generally intended for use in concrete and mortar. And I think the Saudi Building Code explain how to use it and where to use it. But for the standard, we check the quality of the product. We send auditor to take samples and to take sample according to what mentioned in the standard, and we send the sample to lab. And after that, when we get the result, we compare the result with the chemical and physical requirement that mentioned in the standard. If the product pass, we will issue a certificate for the manufacturing. This is what the standard talking about. It's just describing the product, not where to use it, how to use it. It doesn't mention anything about this.
Thank you, Engineer Ahmed. There is Mr. Mahmoud Ahmed. Could you just please ask your question so we can just finish our wonderful webinar?
Just an apology that we have passed more than 30 minutes, and I think we're going to stop to this end of question. And then maybe some questions can be written in the chat and we can reply later because we passed. But go ahead. This will be the last question, please.
Yeah, but I don't know, Mr. Mahmoud, are you still here?
Yes. Assalamu alaikum wa rahmatullah. I will not take a long time. It's just a small question regarding to Mr. Ali regarding how we can increase the awareness for prioritize the using of hydraulic cement in public projects and private projects rather than normal cement, especially in Western area, which we known for using BBC cement since long time. So my question, how we can increase awareness for consultant and the project to make a priority for hydraulic cement? This only my question. Thanks.
with respect to your question, so the awareness, once you have a building codes, you have to comply with the building code. So if there is any, requirements written as, especially for concrete materials, and with respect to, the ingredient of the concrete, I think the code has explicitly identify and illustrate the requirements for each types of exposure categories. As for awareness, I think engineers have some responsibility to educate others, and contractor may find the easy way to do things, but we have upon ourselves some responsibility to educate people, young engineers and practicing engineers, like this webinar, for example, and technical sessions will help that. Plus the authority should do their part in punishing those who cheat, especially at the concrete plants and or contractors at the job site, so that it has to be both education and penalties at the same times. So that my own perspective about this issue. So I hope that I answered your question. So
thank you, Dr. Ali.
Right. I think we're coming to the closing. Thank you, Ola, for facilitating and managing the questions perfectly, like usual. And I think there are more to be talked about. There's still many things. My apology for the rest of the participants, but I am sure Dr. Bassam, Ola, and the rest of the speakers, we took note with a lot of the things that has been discussed today. And definitely we may have some follow-up during the workshop, maybe that is planned in December, or some other webinar. Definitely, of course. In the meantime, as the Dr. Bassam has initiated, or sorry, mentioned in the beginning, the site and the questions and many things that you can find on this initiative, that we really need your contribution. We need everybody to tell us really their stories, if there are good success stories that we can use to move on. We are in the action mode again. We really appreciate King Abdullah University for Science and Technology leading this effort in the kingdom. This is not the first rodeo for them. There's many other projects and many other achievements have been done. We're so proud of what really this entity has really produced for us. And today we are going to be more proud. And I'm very happy and pleased to be here. Thanks for the cement sectors, trusting the academia and others to really help them and support them. And we learned a lot today. And thanks again for everybody. Any final word, Dr. Bassam, or from the speakers before we close?
Yeah, nothing but to thank you first for your contribution, and also to thank all the speakers for their excellent presentations, and also for the participants. Please do, I can echo your words, please come and be involved. We do have the workshop on the 8th and the 9th of December here at KAUST. We'd love to see you. The registration will be via our website. And also the got few people were asking for a copy of the presentation. I will contact the speakers and hopefully we'll be able to facilitate them. It was really interesting to hear about all of this. This is a start of the conversation. It's a very important topic. I have my own views, which I did want to impose about what is green, what's not green, and how do we define it. Also, how to create the pull factor within the market. And I would have loved to hear from Stephen, but we ran out of time. How do we create the demand for so lower carbon cement into the future? Thank you all, and see you in the next webinar.
Thank you. Thank you all.
Thank you. Thank you, everybody.
Thank you all. We really appreciate your presence. Thank you.
Bye-bye.
Thank you very much. Bye.